I'm a staff developer advocate at Pulumi. Espresso writes all of my tweets. She is a munchkin cat. She is 17 years old. Well, she'll be 17 next month, so please wish her a happy birthday. Thank you. Anyway, I didn't get here through like strictly traditional means. I did go to college, but I didn't go to college for computer science, and also I dropped out of college after not very long. I spent a while working as a bartender. I was the resident horror expert at an independent video store for a while, so since it is the month of October, feel free to ask me questions about horror movies as well. I've also been a freelance web developer and a teacher and an embedded Linux engineer for a while. So I've been able to see the tech industry from a ton of different, like very weird angles, and I've had a lot of different struggles. Some of those struggles are universal no matter how you got here, and we aren't really addressing them. One of the ones that I like to tackle with talks like this is that we don't give a lot of context for why we use the tools we use. Like, why are these things helpful? We just say, you use this thing, this concept is good, but why? We don't tell people that. We don't give them the context, and that the result of not giving people the context is that it can take longer to really wrap your head around a tool or a concept or a methodology or whatever than it really should. If you would like to get a hold of me later, that is easy to do. I am on Twitter at Dixie3Flatline, and if you DM me, I will be happy to help you if I have the time and it's within my power. I always try to make time to help people if they have questions. Here we go. First, we have a ton of jargon in cloud engineering, in DevOps especially, just drown in it. And some of this jargon is for concepts that are relatively new. Some of it is for concepts that are really, really old, but that have changed a lot along the way, aren't really recognizable from their original forms. So we end up with entire conference talks, still today, a decade since the dawn of DevOps, about what DevOps means, and whether or not it's a methodology or it's just a tool set, and on and on and on. So there are whole conference talks on that. You should absolutely go listen to smarter people than me argue about whether DevOps is a methodology or a tool set. I'm going to say it is both for the purposes of this talk, but a lot of documentation out there already assumes that you understand this or have context or whatever. So today I'm going to teach you about a core concept of DevOps, and I'm going to give you a history lesson to make sure that you have the context to actually understand why we use this tool. This is going to be mostly useful for like younger people, people who are new to the industry, students, or more experienced people who forgot or didn't work in this corner of the tech industry until pretty recently. Also, it's just interesting. So, CI/CD. We talk about this like it's one thing. We are frequently guilty of this in DevOps. It is not one thing. It is two distinct pieces. The CI is continuous integration. The CD is either continuous delivery or continuous deployment. They do mean different things. I don't like that at all. I hate it actually, but that's the reality we live in. We have two CDs, and you do need to clarify with people what they mean when they say it. I will explain both. Starting with continuous integration. This means merging all developers' working code base with the source multiple times a day. Doing this gets you a faster release cycle, more reliable builds. You catch bugs much, much earlier because with every single commit, ideally, it runs through your pipeline, it gets built, it gets tested, and if something fails, it fails quickly, and it gets bounced back to the developer to hopefully fix whatever is wrong. This is cool. It's also just like a standard practice within software development now. You don't really see teams doing anything without this. This also forces your engineers to write code that's more modular because ultimately other people are going to be supporting your code and extending your code and deleting your code, so it needs to be easy to understand. I know that it can be really, really tempting to get super cute and try to do something real smart on like 2 or 3 lines. But I'm telling you right now, it is a nightmare for not only the next person who has to maintain that, but it's a nightmare for you 6 months later, because I guarantee you that you don't remember why you did it that way or even what that was doing. So resist the urge to get cute. please. It's not best practice. It's also kind of old. Continuous integration has been a thing since the early 90s. It's easy to forget that because we think of it as CI/CD is a core concept of DevOps. DevOps is about 10 years old. I think this year is DevOps' 10th birthday. But yeah, it's been a thing since the early 90s. It hasn't always been called that, and some of the implementation has changed, but the spirit of it has remained pretty much the same the whole time. You make smaller changes, do things incrementally, tiny, tiny pieces, and you do it way more often to make sure that things don't break as often, or at least that when they do, it's easier to track down what breaks. This is cool, this is good, and it's ancient. This was first a thing in '91. Grady Booch was the first person to coin the term in his book, Object-Oriented Analysis and Design with Applications. There have been many versions of this book, but that was the first one. And the Booch method advocated for more frequent use of classes and objects in programming, but his version of continuous integration didn't suggest releasing multiple times a day. We didn't get that until 1997 with extreme programming. This built on the Booch method by advocating for releasing several times a day, and extreme programming changed a lot of things. We got a lot out of extreme programming as a concept, and I know for anybody in the room who is younger and didn't have to deal with extreme programming, the name sounds really ridiculous, and it gives you like incredible 1990s like edgy X Games product marketing vibes, but that's not actually what it meant. That's what it feels like in retrospect, and do I imagine like the X Games splash screen or like Tony Hawk Pro Skater 2 soundtrack going in my head every time I hear about extreme programming? Yes, absolutely. But that's not what they meant. It meant taking things that were already standard practices within software development and taking them much further. So for example, thanks to extreme programming, we have more extensive code review in the form of pair programming. That's just really, really long, involved code review, right? It also got us shorter release cycles and a whole wealth of other things. And from there, we got Scrum and Kanban and on and on and on, all standing on the shoulders of their predecessors to make it easier for us to build software fast. But in the early days, we knew we needed to be doing this, and we didn't really have a great way to make it easy. We didn't get the first open source solution for continuous integration until 2001 with the release of cruise control. If you go Googling for screenshots of cruise control, it's going to look pretty primitive. It looks a little bit ridiculous, but it was revolutionary back then. It was like a big deal. Here's the visual gag I promised. This is not the logo for cruise control. Okay, I could have taken the cruise control logo and ripped the background out of it, but I would have lost out on this joke. This is just a piece of clip art. I couldn't get a version of the cruise control logo with no background because the PNG image format was not widely supported by browsers until Internet Explorer 9, which was released in 2011, 1 year after the last update to cruise control. That's how old it is, and people still use it. Okay, so people actually still use this in production. I wish they didn't, but they do. Regardless, it was really great at the time. For the first time back then, we had a system that we could stand up on our own to automate the management of builds. This allowed us to actually practice that shorter release cycle that we were getting from Booch and from extreme programming and Scrum and Kanban and on and on and on. And it even integrated with your IDE, which was really cool back then, if you were using Eclipse, because cruise control was Java specific. If you were writing like Ruby, you had to use a Ruby variant of cruise control. There were a handful of variants of cruise control, so it wasn't like a massive barrier back then. Eventually, it was overtaken by Jenkins, which is still pretty widely in use today. Supports a ton of languages. It can be made to do just about anything you want. It's pretty convenient, and it has an enormous community around it, so when something does eventually go wrong, when you run into trouble, you're gonna run into trouble with anything this complicated, it's pretty likely that somebody else has run into this problem before and they've documented it for you. So as far as CI tools to use, Jenkins can be pretty great. It is, however, starting to show its age a little bit. You do have to stand up the infrastructure and install it yourself, which some people don't want to deal with. Somebody has to be responsible for maintaining that. This is true to an extent even with Jenkins X, their cloud native offering. There are absolutely upsides to using a system that's completely within your control like Jenkins. It's not my jam, but there are fully benefits to doing that, just like there's benefits to doing anything else on-prem. And then the cloud happened. So out of nowhere, rapidly, we started getting all of these like self-hosted, self-managed CI tools out of the way, and we started seeing things like Travis CI and Circle CI and now GitHub Actions. I don't work for Circle CI, but there are 2 Circle CI employees in the crowd, like grooving over here. So these things also still support a ton of different languages and build environments. They already know how to handle things like Docker and Kubernetes. They integrate directly with all kinds of stuff, your analytics, your deployment tools, your observability. It's pretty great. There is a whole conference talk probably in there on the security benefits of using a cloud solution like Circle CI versus a self-hosted things like Jenkins. I'm not qualified to have that argument. I have opinions, but I'm not qualified to have that argument. Angel is pointing at himself. He's absolutely qualified to have that argument. So if you want to have that argument, talk about it with him. And now CD. So we've got 2 CDs. I hate this, like I said earlier. Continuous delivery means what it says on the box. Your software updates are continuously delivered, but they are not deployed. It's down there ready to be deployed, but it's not deployed. This means that you have the ability to deploy a new build very, very quickly. And a bunch of automated quality gates are being handled by your CI/CD system, like building, testing, standing up infrastructure even, all kinds of stuff. But it's not being deployed, right? And since you're now making all of these smaller, more incremental changes, you have the ability to deploy with a little bit more confidence, right? Because you know that it's a smaller change, it's less likely to contain a big, nasty, game-breaking bug that's gonna lose you all of your customers. And if it does contain a big, nasty bug, you should have the ability to deploy a patch or a rollback or whatever also super quickly. Continuous deployment is similar, but it goes one step forward and automates the deploy for you too. This is a really controversial step for some people, and to you I say, please get over it. Please. If you want to be as efficient as you can, if you want your team to be as efficient as you can, and you want your software to be as secure as it can be, you have to remove human involvement for like these kinds of repetitive tasks whenever you can. I say this a lot. I will say this again in this talk, but humans are really, really bad at repetitive tasks. We get bored, we get tired, we have crappy days, and computers don't get bored or tired or have crappy days unless, like, I guess, I don't know, you've got 42 Chrome tabs running and Slack and Discord, and you only have like 8 gigabytes of RAM, and then your computer's gonna have a crappy day. But like, you shouldn't be doing that on a build system anyway, so it's not relevant. But please, automate the deploy, if you don't mind. Having a human involved in pressing that big green button is not reliability, it is a safety blanket. Whether a human pushes that button or not, you are going to push a bad update one day. It's going to happen. None of us is writing perfect code. It just doesn't exist. So accept the fact that eventually you're gonna deploy a bad update and focus on your ability to correct that as quickly as possible instead. Being able to correct that as quickly as possible means automating your deploy too. I am qualified to have this argument, so I'll be happy to have that fight afterwards, but it is a trust thing. You need to trust your system you can iterate on the tests and whatever else in your CI/CD system. You can't iterate on preventing all of your employees from having a bad day or being distracted. You know, that just happens. It's not in your control. So, CI/CD is just a term for the marriage of these two concepts. It's an important part of DevOps because automation efficiency is what we're all about. We want to go fast. And this gets you a faster, more reliable release cycles. You can add new features or bug fixes, like in however long it takes your pipeline to run. And that's pretty great. Once we get to a point where all you have to do is write code and push it, you don't have to like use your brain beyond that. You don't have to focus on manually running tasks or manually seeing if a thing builds. That sucks. I don't want to do that. That's not fun, and I'm lazy. So this helps you be lazier and write more code more faster. If you've never done this before, you need a CI/CD tool to do this. A lot of them, like these terms have kind of become tangled because a lot of them exist as like one complete package now, and you don't have a separate like CI server and a CD system. You can think of them in your brain as one thing, even though they are two concepts and two tools. But it takes some time to set one of these up at the beginning of a new project if you've never done it before, but I am personally the flavor of lazy where I will spend a ton of time at the beginning on something, making sure that I don't ever have to do it again. It's pretty cool. The details of setting these up varies, but like GitHub Actions and Circle CI are both, so I don't know, 15 minutes for something quick and simple and dirty just to see if you like doing it. And then you set something as a trigger, like watching for a pull request on a particular branch. You tell it a set of steps, usually defined in a format called YAML. There's like ongoing jokes about everybody in DevOps being YAML engineers. This is unfortunately true to an extent, which is why I work at a company that helps me write less YAML. Each with pass-fail conditions like unit tests, building, standing up infrastructure, whatever, and then, or deploy if you're, feeling spicy, if you decide you want to actually take the plunge and deploy automatically too. And with a sufficiently detailed CI/CD pipeline, you really don't have to do anything but write code and push anymore. It is really, really, really cool. Once you're inside of a step in your definition of your pipeline, usually you're just writing bash scripts. Like, that also varies from tool to tool, but frequently it's just bash scripting, and most of us know how to write bash, or bash is well documented enough in the year of our Lord 2021 that you can Google it. But it's great. And now that we know what it is, this is what it actually looked like in practice at various points throughout history. If you're my age or older, I'm 31. Somebody said I looked much younger than I am. I'm 31. I moisturize. If you're on my age or older, you probably remember that software updates used to be a kind of a big to-do. You might reasonably expect to go 6 months or a year without seeing a software update. Longer. It was terrible. They were huge. They were infrequent. The change logs were so large that like nobody even bothered reading them. You just gambled, and you just expected that it was going to break stuff. You expected that it was going to be buggy, and this was normal. This was something that we just accepted. If you are younger than me, that might sound wild because you've never seen this before, but regardless of your age, can you imagine waiting that long for a software update today? Can you imagine like being an engineer and waiting that long to release something? I super can't. Like, I lived through that, and I cannot imagine doing it today. In a lot of situations, it was not actually even possible to download an update. That was not always a thing. The manufacturer would have to provide you with the update via some kind of like physical media, floppy disk, CD-ROM, USB drive, whatever, and this has not been dead and gone as long as one would hope. The last time I had to do this was in 2009. I was updating the point-of-sale software that the video store I worked at relied on to operate, and the manufacturer had to snail mail me a USB drive. They would not email me an executable. I tried, they wouldn't do it, had to mail me a thumb drive, and to be fair, this software also required us to still have a PC with a serial port, which was not a thing that was commonly seen on consumer motherboards at the time because license authentication was done by testing for the presence of a serial dongle. Like it was very, yeah. This is still not entirely dead. You do still see this happen, but it is super infrequent outside of a handful of very specific industries, and it is usually a security concern thing. Or I guess maybe the government, because it's, you know, it's the Fed. So I would love for this to be fully dead, but it's not, alas. Phones have also had problems with the CD side of things. Way back in the 90s, if you wanted like Snake on your phone, you had the Nokia before Snake come out, and you want Snake on your phone, there was no updating that. There was no updating the operating system on your indestructible Nokia candy bar phone to get Snake. You had to buy a new phone. And eventually phones got smarter, obviously, but updates still required plugging your phone physically into a computer to update the operating system. This was the thing with iPhones, this was the thing with Androids until, I don't know, a decade ago or so it was a requirement. I think the last time I did that was on like a Galaxy S4. That was not great. Switching to a new phone required the same thing. Physical cable to move over your contacts, your photos, your apps, whatever. And now, we don't think about it. You switch phones and your stuff is there. There's a setup time, sure, but you don't have to interact with it aside from logging into your like Google account or like entering your Apple ID. And when an app updates on your phone now, you don't know it. It happens while you're asleep. Like, do you know what version the Twitter app is on your phone right now? Anybody? You know the actual version number of the Twitter app on your phone? Ah, okay. Well, there you go. One person out of the room. That's fair enough. So we've gotten much better at this over time, in large part due to the prevalence of cloud computing. That's made it much easier for us to not have to think about these things anymore. However, we still kind of get it wrong sometimes. So modern cars are full of computers. You may be thinking, no, I drive a 2001 Camry. I don't have computers in my car. I'm sorry, but the brakes on your car have been fly-by-wire since the early 90s. You almost certainly have a computer in your car. And it needs software updates. And most of them can't be updated over the air. The one mainstream exception to this is Teslas. They do update over the air. There are a couple more cars now that do it, but it's still like not at all common. And while it's great that they can do that, we see some weirdness with that too. You might have heard of phantom braking. This is still kind of an issue with Teslas, but if not, it's a problem with Tesla Autopilot where the road is clear, good weather, no obstructions, whatever, and it slams on the brakes automatically. It's kind of annoying. It's probably a little bit scary. It might be a little bit dangerous, and it took Tesla a while to fix it. It didn't take them a while because it was difficult to track down the cause, though. It took them a while because of a chess game. So while Tesla certainly has a CI/CD system in place, they weren't using a design pattern that we call continuous updates. They were doing updates in batches, which is usually fine. It is a little bit ridiculous to push out an update for like, you know, one patch, but in this case, it was less than fine, right? So the fix for the phantom braking issue was rolled into a larger update that added a chess game to the car's infotainment system. And is a chess game more important than fixing a phantom braking issue with the autopilot? I would say no, but you got to remember that back then, autopilot wasn't included in all cars. Autopilot was a minority of Tesla cars. So most people cared about the chess game. They didn't care about the autopilot fix. They cared about chess. So we have a situation where an update that's important to a small set of users is delayed because of an update that's important to a larger set of users, and that's kind of crappy if you're talking about phantom braking. Otherwise, is it? Is it actually worse to wait and roll in the update that's important to a minority of users to push it out with one that's important to the most users. I don't agree with Tesla's decision here, but it is a decision that got made. And if they had been using a different design pattern within their CI/CD, we might not have seen this problem. I think the phantom braking issue actually still exists. I could be wrong. It definitely still existed when I wrote this talk in the first place. Turns out it was actually difficult to track down, but the chess update was the first instance of them trying to fix it. It was a little weird that it got delayed because of a chess game, but it is a cute anecdote. It can also get really destructive, not doing this correctly or well, and this is another people are bad at repetitive tasks story. In 2012, a bad software update caused a major stock market disruption and tanked the value of a company called Knight Capital. So they were a trading firm that specialized in making automated trades on the New York Stock Exchange. And one day, it all kind of fell apart, pretty spectacularly. See, they weren't automating their updates or their deployments. They were doing all of this manually, and they weren't doing it very often either. So, like I said, humans are bad at repetitive tasks. We're especially bad at them when we never get to practice them and we're nervous, like everybody coming back to public speaking for the first time in 2 years because we've all been indoors in our sweatpants petting our cats. So 2 things went wrong here. One, the engineer who was responsible for updating the 8 servers that were automating all of these trades, he forgot one of them. And 2, they reused an API endpoint and changed the behavior in the new version, which, maybe it's fine to reuse an API endpoint. I wouldn't do that, but maybe it's fine. You can probably see where this is headed, though. When it went into production, the house caught on fire. Requests to the old server running the old API endpoint wreaked havoc on the share prices of 148 companies. It was real bad. And they didn't have any logging, monitoring, tracing, none of that. So engineers rolled back the software updates on the 7 machines that did get updated, took them offline to do that, which temporarily increased the load on the one that was on the old version, and it just spiraled out of control. This was live for about 45 minutes, and Knight Capital lost $440 million in those 45 minutes. They went out of business as a result. This was a pretty spectacular screw up, but I don't think that engineer was at fault. That was the fault of not having a system in place to prevent something like this. This should have been automated. A human shouldn't have been the one responsible for doing all of this manually. Because again, we get tired, we get bored, and we have bad days. And I feel bad for that guy, and I hope he didn't get blacklisted from the industry afterwards, but it's normal. It's normal to have a bad day and make mistakes like this, right? But if the process had been automated, this might not have happened. The last story here, before I shut her down, is the security angle. This is a story that most of you are probably familiar with. Most of us lived through this recently, though you might not be aware of the cause or how bad it actually was. In September of 2017, Equifax announced that a breach had occurred between May and July of that year. The first month is important, May, all right? So all of our data got leaked, stolen, our names, addresses, birthdays, driver's license numbers, social security, all of it. 149 million people compromised. The hackers had exploited CVE 2017-5638, which was a vulnerability in the very commonly used web framework Apache Struts. And the details of how that exploit actually works are like way out of scope for this talk, but the gist is that it allowed an attacker to remotely execute commands with whatever authority the web server had. And this was not a thing that flew under the radar. This CVE was assigned a CVSS score of 10. It was very, very, very serious. It was immediately check to see if you are vulnerable to this exploit and do whatever you can to fix it at top speed kind of issue. It was not subtle. This vulnerability was also disclosed in March, 2 months before Equifax was even breached in the first place. Once they discovered the breach, a couple months after they had been breached, it took them 2 further months to find and upgrade all of the vulnerable versions of struts. Hackers have remained in the system for something like 148 days or something, completely undetected. It was outrageous. Like, the scale of how badly this was screwed up is actually kind of mind-boggling. Lawsuits were filed. Obviously, we all remember this part, resulting in $575 million in settlements. But because the number of people breached was so high, after attorney's fees, most of us didn't get anything. We just got free credit monitoring, and we get to be paranoid for the rest of our lives. So this was caused by a lack of vulnerability detection. They didn't have any way to know, like, what dependencies were vulnerable to what, which is a problem too, but it shouldn't have taken them 2 months to correct the vulnerable versions of struts. A CI/CD system that's sufficiently advanced would have allowed them to roll out fixes for this quickly, and instead, here we are. So, to wrap things up, CI/CD is a combination of a methodology and a tool set. I don't subscribe to the DevOps as a methodology, not a tool set thing. It's definitely tools too, with the goal of increasing your speed and efficiency as a developer by automating stuff so that you don't have to do it anymore. It's also been around for a lot longer than we like to think. The tools have evolved pretty radically, so have the methodologies. Some of their names have changed completely. But this has taken us from waiting a year or more for a software update to literally not realizing that it's happened overnight. It's another thing that you don't have to worry about as a user, and a whole bunch of stuff that we don't have to worry about as developers, which is pretty incredible to me, looking at the way things were done in 1991 versus the way they happen now without us thinking about it. It's pretty dope. But sorry about the AV issues in the beginning. Again, it is a hard, complicated thing to get right, especially with complicated infrastructure like this. But I hope I've helped you understand the history of CI/CD and given you some context around, like, why we do things the way we do them now, even when it seems a little bit complicated to have to deal with standing up this stuff in the beginning. It is better than the way we were doing things 20 years ago, 30 years ago, more. If you want to get a hold of me, again, my Twitter is Dixie3Flatline. You can try emailing me at work, cat@pulumi.com, but I will warn you that I do not respond to emails with, like, any real level of urgency. So good luck with that. Twitter's genuinely faster. Thank you for bearing with me and sitting through my talk.